Hi, this is Miss Townsend, and we're going to do another video here to help you learn trigonometry. In this case, we're going to learn about different problems that might occur or types of problems you might have to solve using our basic trigonometry. So, just a reminder about what we learned in the last video. We learned the importance of labeling both theta and all the sides of a triangle, opposite, adjacent, hypotenuse. We learned what the fundamental trig ratios were, so sine, cosine, and tangent, and what their ratios represent. We did some questions where we found a missing side length of a right angled triangle. We did some questions where we found a missing angle of a right angled triangle. And we also talked about the decimal rules for rounding during trig. So if you need to, go back and rewatch that video if you're not sure about any of those. So here's what we're going to look at in this video. So first we're going to look at problems where you just have too much information, which sounds strange, but we want to make sure that you have the confidence to work with stuff like that. We're going to talk about something called how do you solve a triangle. So instead of just solving for x, how do I solve a whole triangle? We're going to look at problems involving more than one triangle at a time, and we're going to do some word problems. And just like in my last video, there will be times when I'm going to ask that you pause the video and try to do some of the math on your own. So it's useful to have a pencil or pen, some paper, and your scientific calculator. And just as a reminder, to make sure your calculator's in the right mode, type sine 30 and make sure you get 0.5. That means you're in degree mode, which is what we want. Okay, so have a look at this question. How would you solve for x? So when I look at this triangle, I can see that x is one of the sides of the triangle. But I know two different angles in the triangle. I mean, in fact, I know all three because one of them is the 90-degree angle. But the question really is, which one of these angles is theta? Because I know both of them. I could use either of them. Well, you just have to pick one. It doesn't matter, because depending on which one you pick, you then set up your side names properly and you'll get the same answer. So let's see. I'm going to make this one. I don't know why. I just felt like it. I'm going to call that one theta. So if I call that one theta, now I can label the sides of my triangle. So this side is opposite the right angle. That's the hypotenuse. The hypotenuse hugs theta to show me the adjacent, which is down here. And then, of course, the opposite or other side of the triangle, OPP. So based on how I've selected theta and therefore labeled the sides, I have the hypotenuse and I want the opposite side. So I now need to think about SOHCAHTOA. So, oh, that's the wrong pen. Let's try this one. SOHCAHTOA. So sine, cosine, and tangent, which one of those would I use here? So I want the opposite. I have the hypotenuse. Sine is the ratio that uses opposite and hypotenuse. So I'm going to set up sine 58 equals opposite over hypotenuse. And then I'm going to use my calculator to calculate sine 58. And I get 0.8480. I put that over 1. And now I'm just going to cross multiply. So this times 4 gives me 3.4. And of course, x times 1 is x. So my answer is 3.4 meters. I'm using the units because this question was given to me in meters. So I get 3.4 meters. Now I just want to show you that if you had decided to make this angle theta, fine. If that's theta, well, the hypotenuse is still the hypotenuse. But now x becomes the adjacent side. So this now becomes a question where I want the adjacent, oops, wrong pen, sorry, yuck, where x becomes the adjacent, okay, wrong pen again, and the hypotenuse is known. So I need now to use my SOHCAHTOA, where I'm using the adjacent side and the hypotenuse. And so this would now be a cosine question. So I would set up cosine 32 equals adjacent over hypotenuse. And when I type cosine 32, I get what should be a fairly familiar number, 8480 over 1. And you may recognize that that's the exact same decimal we got. So now I would cross multiply, and again, I would get the exact same answer, 3.4 meters. So as long as you are labeling adjacent opposite properly and picking the correct sine ratio or cosine ratio or tan ratio, then it doesn't matter which one you pick if you have options. So I'd like you to take a moment and try this one on your own. So again, I have two different possibilities as to which angle I'm going to turn into theta. So doesn't matter. I'm going to call this one theta. I don't know why. I just did. So if that's theta, then this is the hypotenuse. The hypotenuse hugs the theta. So this is now the adjacent over here. This is the opposite side. So the sides that I have or want to have are the adjacent side and the opposite side. So which trig ratio uses opposite and adjacent? This for me is going to be a tan question. Look at that. Let's go back to pen. It's not that easy on this program. So tan 29 is opposite over adjacent. So when I type tan 29 into my calculator, I get 0.5543 over 1 equals x over 110. So when I cross multiply, x equals 0.5543 times 110, which is 61. Almost exactly. Hold on, let me just double check that decimal. I didn't record it in my notes here, and I don't want to be inconsistent in my messaging. So it's 60.9, not 61. Come on, Miss Townsend. 60.9 kilometers is the value of x. And of course, you could have done the entire question by calling this theta. And if that was theta, then this now becomes the adjacent side, and this becomes the opposite side. And I still would have used tan, but tan 61 equals opposite over adjacent. And this math would also get you 60.9 kilometers. So, different question now. Now, the question says, how would you find angle D? So have a look at this triangle. So we've actually given the sides names now. So angle D would be this angle. And how would you find it? Well, we know that we can find the angle in a right angle triangle if we know two sides. But here I know three sides. So again, you have some choice to make. Just make a choice. I know that this is theta. So there's no choice in how I'm labeling my triangle. That's the hypotenuse. I'm going to come around here, hug theta. That's the adjacent, and then over here is the opposite side. But I can choose from SOHCAHTOA because I know all the sides, so it's sort of dealer's choice here. I'm just going to pick sine because, I don't know, it's written first. So I'm going to say sine theta. So sine theta is opposite over hypotenuse. So sine theta is opposite over hypotenuse. And I could have also written D here instead of theta. I mean, my answer should probably have D in it, but I guess I'll fix that. Not that it really matters. The math is the math, but let's be consistent here. And so all I want to do is find D, so I just need to get rid of sine. So this is where sine sort of moves to the other side and becomes inverse sine. So this is nice. It's just a button on my calculator. Don't forget to use the brackets here. So I get that angle D, which you often write with this little symbol to mean angle. I know it looks a lot like the greater than less than, but it's meant to be more like that instead of like that. It's hard to draw. So in my calculator, if I do inverse sine on 48 over 73, I get 41 degrees. So don't forget it's an angle, so I want it rounded to the nearest integer. So I got to pick sine, cosine, tangent, and regardless, if I had decided to use cosine, then I would have done this in my calculator, inverse cosine of 55 over 73, because I would have used the adjacent side, but I'd still get 41 degrees, and similar if I'd used tan. So here's a question I'd like you to try on your own. So angle K is what I'm looking for. So angle K is right here. So that's my angle of interest. So I can say this is the hypotenuse. Walk around here, and I've got the adjacent. And then over here is the opposite. So just like in the last question, I know all the sides. So I can decide to use whichever sine, cosine, tangent I want. I'm going to use sine again just because it's sort of, I like it as the default. So angle K, or theta if you want. So I need opposite over hypotenuse. So the opposite side is 209. Sorry. I started coloring in adjacent there. Ignore that. I still don't edit my videos because I barely have time to make them. So I need opposite over hypotenuse. SOHCAHTOA. And so sine K would be 209 over 241. So I just need to solve for K. That means take sine and get rid of it by making it inverse sine on the other side. Using brackets, I just type that directly into my calculator, and I get that K is 60 degrees. Okay, so now let's talk about just terminology. Sometimes you'll be asked to solve a triangle. So not solve for x or find an angle, but literally solve the triangle. And what that means is that you need to find all the side lengths and find all the angles. So there's 3 sides and 3 angles. You should know all of them at the end of a question. So before we get into an example, I just want to spend a moment and talk about naming the sides of triangles. So this is not naming the sides opposite, hypotenuse, opposite, and adjacent because we're in the middle of a trig problem. This is just the general rule for what do we call the sides of a triangle. So first of all, the triangle on the left has its corners or vertices. That's what they're technically called. PQR. So the name of this triangle is PQR. So we would call that, hey, hello, my name is triangle PQR. And of course, this little symbol here, which literally is a triangle, means triangle PQR. Now the sides are going to get the same letters. There's going to be side P, side Q, and side R. But the problem is, well, that if I wanted to say which one's side P, is this side P or is this side P? Well, there's no universal way of defining side P to be either of those. Therefore, we choose none of those. So the 2 sides that P are touching are not going to be the side that we call side P. Instead, we go to the opposite side of the triangle. So trace to the opposite side. And then that means that P is pointing at its best friend, side P. And when we identify sides, we use lowercase letters. So P is kind of hard to tell it's lowercase, so I use that little fancy, like, as if I'm writing it. So therefore, if this is angle Q, on the opposite side of the triangle is little q. And this is side R, so on the opposite side of the triangle is side R. So lowercase letters for the sides, capital letters for the name of the triangle, which is the vertices. So let's look at another example. This is triangle DEF. It actually does not matter. I could have also said triangle EF or FED, whatever. You do tend to go alphabetical because, well, that's kind of an order that we're all familiar with, but it's not automatically wrong if it's not alphabetical. So here's angle D is right here. So on the other side of the triangle would be side D. Here's angle E. So on the other side of the triangle is side E, and angle F. So on the other side of the triangle is side F. So that's how you can give a name to the angles and sides without having to use opposite and adjacent, because not everyone is picking necessarily the same theta in every question, which means that opposite and adjacent aren't automatically the same for every person. But that's how in the math world we talk about the sides and angles of a triangle. So let's look at this question, solving a triangle. So it says to solve triangle ABC. So that means find all the missing sides and all the missing angles. So the first thing is I'm going to give names to the things that don't have names right now. So this is angle A. So over here would be side little a. This is angle B. So this is little b. This is angle C. So this is little c. I might also probably need to name them hypotenuse, opposite, adjacent, but not until I'm ready to solve. So my goal is to find all three angles and all three sides. So this little chart here can help me keep track of that nicely. You'll notice there are three sides, lowercase letters, and three angles, capital letters. And I already know some things. So I already know, for example, that this side, side B, is 9. And I know, those clicked in the wrong order, darn it. And I know that this angle is 55, that's angle B. And this angle is 90, that's angle C. So I can now see that I can really easily find angle A. So we know that all the angles in a triangle add to 180. So I already have 55 degrees and I have 90 degrees. So whatever is left over is what angle A must be. So if I subtract 90 and 55 from 180, I'll get 35 degrees. So now I have found all the angles in my triangle. I only have one side, so I'm going to have to use trigonometry. So let's, I don't know, I'll find A first. Totally doesn't matter. Again, you sometimes have a lot more choice in a trig question. So I want to find this side of the triangle, and I know this side of the triangle. So now I'm going to name the sides just temporarily, opposite, adjacent, hypotenuse, so that I can use trigonometry. So I'm going to say that this is theta, only because it's already on the diagram. And then this side is the opposite side. No, it's not. Oh my goodness. Boy, oh boy. I hope you caught that. Ooh, see, everybody makes mistakes. This side is the hypotenuse, because it's opposite the 90. Then if I trace around theta, this becomes the adjacent, and this is the opposite. So in order for me to use trigonometry here, I can see that I'm looking to find right now the adjacent side, and the side that I know about is the opposite side. So opposite and adjacent, that means I'm using the tan ratio. So tan of 55 degrees is opposite over adjacent. So you can call it X if you want. It happens to be that A is the adjacent, so I could just say A. Just sometimes in my handwriting, an A and a 9 look a little too similar. So I'm just going to call that X. The thing I want is X. So when I go to my calculator and I type in tan 55, I get 1.4281 over 1 equals 9 over x. So if I cross multiply, 1.4281x equals 9, and then divide by this decimal on both sides. So in my calculator, I'm going to calculate 9 divided by 1.4281, and I get that this side is 6.3. There's no units, like I don't know if it's measured meters or kilometers, so I don't need to put units. So now I know that this side is 6.3. Now I have to find side C. So again, I could use trig again, certainly. Or, why not? Haven't done this yet. If I know two sides of a right-angled triangle, I can calculate the third using Pythagorean theorem. So that's what I'm going to do. c squared, and it does conveniently happen to be that c is the hypotenuse, so that's nice. C squared equals a squared plus b squared. So c squared is equal to, hold on, 6 minus using my calculator. So c squared is equal to 120.69. And then when I square root that, I get basically 11.0. And you would get 11.0 if you had, for example, used trig again and said, well, if that's theta, this is the hypotenuse, and that's the opposite. So you could have also set up sine 55 equals opposite over the hypotenuse and solved it that way. You would still get 11. So I now know all three sides and all three angles. Okay, try this one. So again, I'm trying to solve the triangle. So the first thing I'm going to do is figure out what information I start with. So I start, let's see. What do I start with? This is side little j, and that's 113 centimeters. This is side, hold on, little g, and I know that little g is 42 centimeters. And this side must be little h, and I don't know what it is right now. I don't know angle G. I don't know angle J, but I do know that angle H is 90 degrees. So that's the information I'm given. You know, typically given about half the information. Oops. Where am I? Where are we? We're here. Okay, my bad. So now let's look at what information we can use to start solving. So let me just get rid of some of that stuff. So for example, side H, I can find side H because it is the hypotenuse of a right angled triangle, and I know the other two sides. So that's convenient. Might as well use that. We don't always have to use trig. That's one of my first video. I mentioned the Pythagorean theorem is important, all that stuff. So side H squared, so again, this is side H. So side H squared is 113 squared plus 42 squared. So if I do 113 squared and then I add 42 squared, I get a nice big number, 14,533. And then I'll square root that, and that gives me 120.6. And we're measuring in centimeters. So I can put here that this is 120.6 centimeters. Great. So I've found all the side lengths, but I don't know any angle other than the 90 degrees. So this is where trig is going to have to come in. So I need to figure out one of the angles first, and it doesn't matter. I'll use this one. So I'm going to call that theta, which means this is the hypotenuse. And then circling around theta gives me the adjacent. And on the other side of the triangle is the opposite. So I'm not going to use the hypotenuse because I may have made a math mistake, whereas I know for sure that the opposite and adjacent are correct because I was given them. So I'm going to use the adjacent and the opposite. So that means I need to set up a tan ratio. So tan theta, it's angle G, but that's okay. It's theta, it's G, it's both, equals opposite over adjacent. So solve for theta means move tan where it becomes inverse tan. And then this, I just type into my calculator, and I get 20 degrees. So rounding to the nearest whole number, it's 20 degrees. And then, of course, how do I find angle J? Well, I could do another tan step, but instead I'll use the other fact, which is that all angles add to 180 degrees. So in a triangle, The sum of the angles is 120. So these two together add to 110. Sorry, did I say 120? Wow. All angles in a triangle add to 180. So the two that I know add to 110. So if I subtract, I get 70 degrees. So that is the triangle. Sorry. Okay, I hope I'm recording still. Yes. Whew. Okay, moving on. So other questions you might have to deal with include working with more than one triangle. So here's an example of what I mean by that. That what I see here is a right angled triangle on the right. You can see the 90-degree angle. And then there's another one pushed up against it on the left. So because we're still working with trig, then we need to sort of think in terms of right angled triangles. So we know, for example, that this angle here must also be 90 degrees. So we have two right angled triangles touching each other. Now our goal is to find x. Sorry, something keeps happening and I'm not going to edit my video. So we know that side x is part of the triangle on the right. So it's part of this triangle. So if I focus for a second on just that triangle, how am I going to find x? Well, I know two of the angles, but I don't know any of the other sides. So that's going to be really hard to do. So instead, I'm now going to focus on the left triangle, which is now highlighted in green just to emphasize the different triangles. So I can't just start with finding x because, again, if you look at the pink triangle, I don't have enough information. I only know two angles. I know none of the sides. But if I focus on what's happening on the green triangle, I can find stuff out. And what's really important to notice is that the green triangle and the pink triangle, well, they share a side. This line is a side of both the triangles. So if I can find the length of that blue line on the green triangle, then it's the same length on the pink triangle. And you can see that for the green triangle, we have enough information. So I'm going to focus for a minute just on the green triangle, and I'm going to try to find the length of that blue line. So on the green triangle, I'm going to obviously call the angle I know theta, which means that here's the right angle because it shares that line, so it must be. So over here is the hypotenuse. And if I wrap around theta, I get the adjacent. And this blue side over here would be the opposite. And that's the side I want because the green triangle isn't that interesting. I just need to use it. It's the pink triangle that's important, and that's the line that's shared, which means that the sides I'm going to use in my trig are the hypotenuse and the opposite. So because I've already got x identified, like I can't introduce another x, I'm actually going to name this blue side. Well, I've already named it blue side. But just for the purposes of math, I'm going to call it y. Because why not? No, because there's already an x and y makes sense. So again, focusing just on the green triangle, I'm setting up opposite over hypotenuse. So I'm going to set up the sine ratio. Sine 67 is opposite, which I don't know, but I've named it y, over hypotenuse. So I can get my calculator to tell me what sine 67 is. Turns out sine 67 is 0.9025 over 1, y over 16. So when I cross multiply, I end up with y equals 14.7. So now I know the length of that blue line is 14.7. So now I can focus on the pink triangle. And on the pink triangle, this is theta. And if that's theta, boop, 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 now I've got this hypotenuse. X is the adjacent and y is the opposite. So using this triangle, I would say I'm looking for the adjacent side, and I know the opposite side. So in this case, I'm now going to use a tan ratio and say that tan So tan of 48 is opposite 14.7 over adjacent. So now I'm just going to solve for x. So tan 48 in my calculator, 1.1106 over 1. And now I cross multiply. So 1.1106x equals 14.7. Divide both sides by this number. So in my calculator, 14.7 divide it by 1.1106 gives me 13.2. And I can see that I was using centimeters. So that is 13.2 centimeters. So here's another one. I'd like you to try this one, please. Okay, so once again, I can see that I basically have two triangles here. There's the green one and the pink one. And x is in the pink one, but I don't have enough information to just tell you x right now. So I'm going to start with the green triangle and notice that there is a line right here that is part of both the green and the pink triangle. So I'm going to call that y so that I can give it a name, use it in my formulas, and if I can find y, I can use it to find x. So again, focus just on the green triangle. I'm going to call this theta. So boop, 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 boop. This is the hypotenuse. If I circle around theta, I get the adjacent. So y is the opposite side. So in the green triangle, I have the hypotenuse, and I'm looking for the opposite. So which trig ratio uses hypotenuse and opposite? Well, if I'd said opposite and hypotenuse, might have got there faster, but we know this is a sine question. So sine 43 is opposite over hypotenuse. So if I type sine 43 into my calculator, I get 0.6820 over 1 equals y over 8.4. Cross multiply, you get y equals 5.7 meters. Now I know the length of this line is 5.7 meters. So now I can switch my focus entirely to what's going on the pink triangle. So now I'm going to call this theta. And the right angle's here, so this is the hypotenuse. Circling around theta tells me the adjacent, and the other side is the opposite. So again, focusing on just the pink triangle, I can see that I want to know the hypotenuse. Oh, I don't like that very much. Oh well. And I do know the opposite. It just erased there. Oh, I did it. Okay. Weird. Okay, so I want to know the opposite. Nope, I have the opposite, which is 5.7, and I want to know the hypotenuse. So again, this is going to be a sine question. So sine, So sine, not trying to, oh, I'll use red. Oh, well. Sine of 72 is opposite over hypotenuse. Pen's going a little crazy. Wouldn't it be nice if I, edited, but that won't happen. It's more like being in class when I make these boo-boos and get distracted by things. So in my calculator, sine 72 is 0.9511. And over here, it's 5.7 over x. So I cross multiply to get 0.9511x equals 5.7. Then divide everything by that number to give me x equals about 6.0 meters. Okay. So now let's talk about word problems. So the best advice for word problems is draw a diagram, and then just as always with trig, be careful what sides you're labeling. So before we get to the word problems, just some new definitions. There's something called angle of elevation and angle of depression. As human beings, yay, look at my drawing, our eyes are situated in our head, which means the most comfortable thing for us to do is to look straight forward, right? Like that's how we're designed, to look straight forward. But sometimes we have to look up and sometimes we have to look down. So if you are looking up instead of straight forward, then the angle formed between where your natural forward look and how you're looking up. This is called the angle of elevation. So it's the angle looking up, like going in an elevator takes you up. But if instead you're not looking forward and you're looking down, so you're on something tall or whatever, and then you're looking down, that's called an angle of depression. And again, it's measured to the horizontal. So we'll see those words in some of these word problems. Here's the first one. From a spot 30 meters away from the base of a tree, Aaron looks up to the top of the tree with an angle of elevation of 48 degrees. How tall is the tree? So let's try to get a diagram here. So obviously we're looking for some sort of right-angled situation. And just so you know, we always sort of assume things like trees and buildings, even though I'm not drawing it correctly, are going to be 90 degrees to the ground. Ooh, that one worked okay. So this tree is 90 degrees to the ground. So from a spot 30 meters away, so here's the base of the tree, 30 meters away. Aaron is looking up to the top of the tree, close enough, pretend. And the angle of elevation. So remember, that's the angle from, instead of looking straight forward, you're tilting your head up. Angle of elevation is 48 degrees. And we want to know how tall the tree is. So I hope it makes sense how to create a diagram. And here is a nicer, prettier diagram where we can see that we are viewing from a distance away, 30 meters away to be exact. The angle of elevation is 48 degrees. And I'm looking for the height of the tree, which would be this. So I'm going to call that X. You might be tempted to call it H for height. But because we have like hypotenuse, we don't want to get confused by using the letter H in a different way. So I'm just going to call it X. And now I'm going to use trig. I want to know the height of the tree. And so I'm going to say, well, this is theta. And over here would be the hypotenuse. So if I circle around theta, I'm at the adjacent. And of course, over here is the opposite side. So let's figure out which trig ratio we want to use. So I want to know the opposite side. And I currently do know the adjacent side. So SOHCAHTOA, which of sine, cosine, and tangent? It's going to be the tan ratio. So tan 48 is opposite over adjacent. So in my calculator, tan 48 gives me 1.1106. I put over 1. And then if I cross multiply, I can get x equals 33.3 meters. So the tree is 33.3 meters tall. This, by the way, is like how trig, has actually been used for centuries and millennia to find the height of unknown, like things that we can't actually measure directly. Let's look at another word problem. So again, reading carefully, see if you can make a diagram. From the top of an 80-meter tall building. Okay, so right away, I'm going to draw a building. Now, again, we want our buildings to be perpendicular to the ground, so this was just to pretend that's not happening. This is 80 meters. Oh, boy. So 80 meters from here to here. And from the top of the building, Brina must be at the top of the building, and she looks down, whee, and she sees her car. Now, what we know is that when she's looking down, there's an angle of depression of 71 degrees. Now, be careful with angle of depression, because you always have to remember that for a human who's looking at something, the natural way to look is straight across. So if we're not looking straight across, we're instead looking down, then the angle with which she's looking down, that is the angle of depression. Notice that it's not in sort of the triangle that is the trig triangle of the question. So like this is the triangle that I'm going to use, but that 71 degree angle is sort of outside the triangle. So that's a really important thing to notice. So first, here's a prettier picture. So again, just adding the information we just talked about. Oh, it's all purple. Should I use purple? No, I'll use a different color. So we know that this is 80 meters. So the height of the building. And don't worry about things like, well, how tall is Brianna? Because her eyes are not actually on the roof. They're whatever. Don't worry about that. That's stuff for when you've mastered trigonometry. Not for stuff to worry about. So we know that that's 80 meters. We talked about how the angle of depression here is 71 degrees. And we're asked to find how far away is the car. So we're asked to find that distance. And then, so what do we do with that 71 degrees? Well, there's a couple things we could do. And you choose whichever one you like best. But we know that between straight across and straight down is a 90-degree angle. And we know that 71 degrees of it is taken up by this piece. So if I do 90 minus 71, I get 19 degrees. That's the actual angle in my triangle. Just to show you what the other approach I see students take is, if you remember well your parallel line theorems, there's a backwards Z parallel system. And in a backwards Z, any Z parallel line system, the angle in the corner of your Z, so corner of the Z, corner of the Z are the same. So I could also say that this is 71 degrees, but I'm not going to. I just go first thought, 90 degrees, so it's 19. So to do this question, just to draw just the triangle we're interested in, we have this is 80, and pretend it's straight up. This is 19, and then this is x. So we'll call that 19 degrees theta. So here's theta. So this is the hypotenuse. Wrap around theta. This is the adjacent. Oops. Oh no. Hold on a second. Am I recording? Okay. Sorry. Technical glitch right there. So we were labeling hypotenuse, right? Hypotenuse, wrap around here. That's the adjacent. And this is the opposite. So which trig ratio will I use? I know the adjacent side and I want to know the opposite side. So this is a tan question. Tan is actually a really popular one in the real world, you know, where it's easy generally for us to measure straight up down things as opposed to diagonal lines. So I'm going to say tan 19 is opposite over adjacent. When I type tan 19 into my calculator, I get 0.3443, and then I can cross multiply to get x equals 27.5 meters. So how far is the cat or car? Whatever. It's 27.5 meters away from the base of the building. And then here is a word problem where the diagram's given, which is great. Sometimes it's given. And there's more than one triangle. So from her hotel room, which is 5 meters off the ground, so that's marked, that's 5 meters off the ground, a tourist has a clear view of both the bottom and the top of a historic clock tower. So there's a clock, that's the clock tower. The angle of elevation to the top is 57. The angle of depression to the bottom is 35. So she's in her room, 5 meters above the ground. She tilts her head up and says, oh, look, the top, 57 degrees. Then she goes back to neutral, straight across, tilts her head down. Oh, look, there's the bottom, 35 degrees. So we've got to answer two questions, one of which is how far from the hotel is the tower? So I'm looking for this distance, and then we'll be looking for how tall is the tower. Okay, so just to clear the space, feel free to pause if you want to try this on your own. How far is the hotel from the tower? So on this diagram, that is this distance. That's what I'm looking for. But you'll notice it's the exact same distance as this. Those are the same distances. So if you look at just the lower triangle, there's a lower triangle like this, where we have a 35-degree angle here. We know that, hold on. Oops, wrong one. Wrong one. Here we go. We also know that this distance is going to be the same as this distance. So this is 5 meters. And we're looking to find what this distance is. So I'm just going to call it x. And so classic trig, theta is here. This is the hypotenuse. This is the adjacent. That's the opposite. So I want the opposite. I know the adjacent. Oh, look, it's a tan question. So tan of 35 is opposite over adjacent. So tan 35, type that into your calculator. Did I do it in advance? I didn't do it in advance. Okay, this is live math happening now. Tan 35 is 0.7002. Put that over 1. And then if I cross multiply, ooh, this is messy, 0.0, so that 0.7002 times x equals 5. Divide everybody by this number. So in my calculator, 5 divided by that gives me 7.1. So the clock tower is 7.1 meters away from the hotel. Boom. Those are done. Now it also asked me what's the height of the tower. So the whole tower goes all the way from here to here, obviously, but we already know part of the height. What we know is that this distance here is 5 meters, right? Because that's the same height above the ground as where that person in the window was looking up and down, which means I really only need to find this distance and then add it to 5. So I'm going to call this y. Again, I don't want to call it x because I called something x already in the question. Let me give myself some workspace here. Goodbye. Oh. This is the best part of a video, right? When like, it's as if you're in class and I'm just doing something that another teacher would have prepared in advance. I don't know. So I call this y. So now have a look at this upper triangle. We know that this is 90 degrees because that's how angle of elevation and depression look. So this is 57 degrees. I want this, and I know this distance. This distance is the same distance I just calculated. That's 7.1. So using trigonometry, we're going to call this theta. Here's the hypotenuse, wrap around. That's adjacent. This is the other side. So the information I have or want to have is I want the opposite side. I have the adjacent side. Oh, look, another tan question. So tan of 57 is opposite over adjacent. So if I type that into my calculator, I get, hold on, tan 57, and then do that math. I get y equals 10.9 meters. Now remember, that's not my final answer. The height of the tower is 10.9 meters plus 5 meters. So it's 15.9 meters as my final answer. Okay, so what's the key learning in this video? Sometimes you're given too much information and you just have to make a choice. Which side do I want to use? Which trig ratio? What angle? We learned that solving a triangle means finding all the sides and all the angles, all 3 of sides and all 3 angles. We've learned about angle of elevation and angle of depression. They get used quite a lot in word problems. And we've learned that in general in trig, if you're given a word problem and you don't have a diagram, draw one. Okay, so my next video for this series will be on triangles that aren't right angled, and we'll talk about the sine law and the cosine law. Thanks for watching. Go do math.